Okay, it seems a good time now to run a demo of our current system with the Fly-by-Feel project. This is the overall setup with hardware and software. Um, on the right here is one laptop running X-Plane Simulator. We could be running the software all on one, but X-Plane Flight Simulator takes up a lot of CPU, so it's kind of useful to run it on the right. It's running a plugin that we've developed that acts as a server for the software on the left. This is running software written in Java, and well, some of it's written in C and C++. And what we're going to do right now is start to show you some sensory visualization from X-Plane Simulator. We're obtaining data from the wings of the aircraft that's going to be flying here. We'll put it into a chase mode here. This is a Cirrus aircraft, happens to be, oops, here we go. And we'll activate the force display, generating, using the force data from the lift of the wings, and we're going to be streaming that back and visualizing these as sensors in this blue area. What's blue is indicating low pressure right now. And the hardware off to the left here, this is tactile feedback hardware that we've been prototyping. Jordan Parrott's hardware here. 16 pager motor sleeves, right sleeve, left sleeve, and we'll show you that in a bit. Alright, so we're going to show you a demonstration of, on the left, the sensor visualization, and on the right, Cirrus aircraft. I'm going to start the Cirrus aircraft in autopilot mode here. And what you should see is that center panel, that blue, those two rows of blue on the left are going to start to turn different shades. It's representing the force vectors over the wing of the aircraft on the right. You can see the force vector growing on the wing of the aircraft on the right as it takes off. And it's from wing root to wing tip on both wings, top and bottom. Are representing left wing and right wing, I believe, but the left is wing root, the right is wing tip on the left panel there. And it's aircraft's in a bank to the left. I'm not seeing much variation there, left wing to right wing, maybe because it's a relatively coordinated flight. I'm not 100% sure of that at the moment. But we're having this visual rendering of the forces over the wing coming back into our software written in Java and C++ on the left. We've got a cat in the background, which is just an extra bonus for the demonstration. Alright, well, next I will hook up the tactile feedback hardware, and I will give you a little bit of look of what that, give you a bit of sense of what that looks like. Alright, so I'm going to give you a little bit of an idea of what tactile rendering hardware looks like here. This is the right sleeve. It's got two bands of actuators, 4 on the top, 4 on the left, 4 on the bottom. These are pager motor, pancake pager motors, and they're designed, this sleeve is designed just to be up on near the shoulder here. So that's the right one, and corresponding symmetric left one. These are hooked in through serial cables. It turned out there was the right number of pins on there, but not using serial interfaces, just driving with a microcontroller and some A to D converters over here on the hardware. And I will, in our software, I will choose the tactile render sensor data option here, and hopefully well, that didn't work. Okay, well, it's always good, right? Well, it would be a problem if the USB cable is not connected. Using USB interface to talk to the microcontroller from C++ and then to the Java. So let's try that again. So we now have the USB cable hooked in, and we'll say tactile render sensor data, render from data source, and now I'm actually feeling effectively feeling representation of the wing force data on my arms. This time the biggest distinction is between being on the ground and being in the air. This is our first prototype hardware, first cut at mapping from the sensor data to the tactile feedback actuators. So we're in the process of getting the fine discriminations of the distribution of the forces on the wing mapped back to the way it feels on the arms. You can see the tactile feedback actuators, but you can see the sleeves. You can't actually see the pager motors that are embedded in the fabric. Alright, well that's our first demonstration.